Okay, wonderful. I can see the number of participants going up and up. So it is my pleasure to welcome you all again to another iteration of the Security Middle East webinars. I'm delighted to be collaborating today with two organizations, OWL Cyber Defense and Oregon Systems. As always, my name is Daniel Norman. I'm the webinar chair for the Security Middle East magazine. And it's my pleasure to introduce this webinar today. So, on this webinar, we will be exploring the interfaces between OT and IT infrastructure, especially in critical sectors such as manufacturing, energy, retail, and many other critical national infrastructure providers. And that convergence is something that comes up very frequently in discussions we have with chief information security officers, heads of cyber risk, head of OT, and building a homogeneous controls framework and systems that protect both elements of the infrastructure is absolutely key. And an area that we're looking at today is data diodes that provide hardware-enforced one-way data transfers, which ensure absolute security of high-speed file transfers. Now, what you'll be learning today in the webinar is how do database replication and OT system monitoring, essentially, how can we deploy that to address challenges such as real-time monitoring, compliance with regulations, etc., and the core features that our Talon suite of data diodes can provide. Now, I'm joined by three individuals. Firstly, John McKeon is the Director of Global Partner Sales at OWL Cyber Defense. He's got a tremendous amount of experience as a Managing Director of ITG, of course, working in the US intelligence community, as well as investors or providing, should I say, technology solutions to large institutional investors and hedge funds. Now, working alongside John is Rohan, who is a senior technical consultant specializing in OT and IT, with, again, many years of experience, especially across the Middle East in cybersecurity, network domains, solutions architecture, etc. And last but not least is Phil Wong, who is a senior product manager at OWL Cyber Defense, where he's been leading the product definition, development, go-to-market planning, and the launch of core cybersecurity platforms since early October 2018. Now, it's my pleasure to hand over to John, who will be kicking off the webinar today. John, over to you.
Thank you, Daniel, and good afternoon, everyone. Thank you for joining us. So today, as Daniel alluded to, we hope that by the end of this session, you will have learned something about the challenges around securing high-speed file transfers and replicating data from OT environments to IT environments, and specifically why data diodes should be considered as addressing these challenges. And we'll also cover in some depth the core features of the OWL Talon suite of data diodes. So what is the core challenge that we face? So primarily, I mean, data diodes and cross-domain solutions, which is really our core business. It's all that we do is help customers move data from between networks of different domains. The primary challenge that we face on the commercial side is moving data from OT networks that are air-gapped or potentially should be air-gapped if they're not already, and moving that data out to an IT network or a different portion of the customer's network where it can be utilized for business value. So think of all this data that we have inside of plant facilities that is very valuable that we want to be able to share and get real business value of, especially today, being able to use that data in modeling and machine learning to be able to improve the operation of other plant facilities in your environment. But of course, the threat of connecting any operational network to the outside is high. And so the real solution is to apply a data diode to that chain to allow and enforce at the physical layer that data only moves one way out through the network. And I'll talk a little bit about how that works and some of the principles. So a key point about data diodes is that we're trying to enforce as much of the security policy as we can in the hardware itself. So when the data diode is used in that way as a physical control, it's very different than almost every other technique that you could use besides just air gapping and unplugging completely, in the sense that a firewall, even as an appliance, is still at its core a piece of software. So that software enforces a set of rules. It allows one network to talk to another in a predefined way. But like any piece of software, there's of course the chance that there's a flaw in the software that could be exploited. Perhaps that flaw has been discovered by an attacker before a patch has been developed. Even if a patch has been developed, has it been deployed in time? And frankly, when you see, I'm sure most of you know from the news that when there is a firewall based attack, it's typically not even a sophisticated hacking of the firewall. It's normally a scenario where a firewall was simply left misconfigured, and an attacker was able to traverse it. Whereas the data diode is a physical control. We enforce one-way movement of data at the physical layer. And so no matter what the software is that's placed there, there's no possibility of data going in the reverse direction. So I'll talk a little bit about how that works. So this diagram illustrates a typical data diode configuration. There are many different form factors, as you'll see later when Phil gets to the product portion of the demonstration. But if you look at this gray box that surrounds the components on the screen, imagine that as a 1U rack mount appliance where you don't have two servers of one server, and rather you have two servers. You have one that serves as a proxy on the source network, so in this case on the operational network, and that server will receive data from the operational network. It can have two-way communications with the operational network. But once the data is received on that source side proxy, all of the routable information would be removed from it. So no IP addresses or MAC addresses would traverse to the other side. And the source server has a capability to transmit data only. So in this case, in an optical example, we show that the source side has a communication card that can only emit light. On the destination server, the red server on the right, it only has hardware that can detect light. So we intentionally build the solutions without the hardware required to send data in the reverse direction. So when the data is received by the source, the destination proxy, we have to independently have configured that for what we want the system to do with that data, because obviously it doesn't have any communication with the source side. And so we'll configure there where that data should go. So in the simple example of an email address, you would send your email to the IP proxy on the left side, the source side, to that IP address, which belongs to the OT side. And then when the data makes it across to the destination side, that server would know where to send it to, for example, your Exchange server or Office 365. And so this allows us to connect the networks and exchange data. However, the source network, the OT side, has no idea where the data is ultimately going. The destination side has no visibility into where that data came from. But yet we're able to move that valuable data out of the OT network with no possibility of any data getting back into the plant and causing an incident, a ransomware event, an outage, or potentially even physical harm. So with that, I'll turn it over to Rohan to get a little bit more into some of the use cases.
Thank you, John. So in today's discussion, I'll be just taking into consideration like three common use cases, what we have deployment across the region. So first being a file transfer scenario, I'll be discussing some services which we can use in the database replication side, specifically for the OT side of it. And another common use case, what we have deployment here is in the system monitoring part of it. So just before starting this whole discussion, I just want to establish what is the architecture we are discussing here. So let's say if I take an enterprise with two different security zones with its own risk profile, you have like a separate security requirements. The ideal way will be like, say you have like completely two different networks and you don't want to connect it, and your asset owner doesn't want any asset to have a direct communication. So this will be a scenario where we'll be building our solution on. So let's take the challenge here. So if I take an enterprise as a use case, so a normal enterprise, we will have like use cases for like there will be like a backup solution which generating snapshots, daily backups, hourly backups. So there's a huge volume of files getting generated. Now we have like solutions like antivirus, threat feeds, there will be Microsoft updates. All those things will be part of an enterprise use case scenario. The challenge here is that, okay, you have your traditional data diode solutions, which goes up to 10 Gbps use cases. So when your enterprise start growing, you have like huge volume of data which is coming through this data diode now. So when you start scaling, you will be doing a horizontal scaling where you start adding more data diodes and match a specific application use case to a specific diode. So this will be a traditional way to look at this problem. The newer solutions, what Owl has provided, like Talon torrent cards, which provides 100 Gbps. So compare it to your traditional, the older generation of diodes. Let's say if I take a 10G diode, which was the from Owl previously, the newer generation, you can go up to 100 Gbps. So you take the same security what John was explaining in the previous slide. You have this optical isolation, the highest level of assurance that your data flows in one direction. Now you have a more throughput and performance out of the same size, same box itself. So you have more performance and you can push more data through this solution. So Owl provides you this base file transfer services part of your design. So when you are a cybersecurity engineer, you get all these tools. So this is a basic file transfer solution what I'm discussing here. So we have partners and partner ecosystem where people have developed other solutions using Owl as a transfer mechanism. I'll give you examples like, okay, we recently had a project where like the customer, they were using diode as a transfer mechanism for their day-to-day update services. So they have like complete automated data pipeline for Windows update, which comes from the internet. They get transferred safely through the diode, then automatically get imported. There's no human intervention in this whole process. There was like automated antivirus updates getting pushed through the diode and safely ingested into the AV system. So if you think about the file transfer, it's like a base component service Owl provides. So we can build other components on top of it, which uses Owl as a backend service for transfer of files. So there is another use case specifically in the OT side where we have like a Honeywell PhD historian where they utilize Owl as a file transfer mechanism. In that case, they use file transfer mechanism to move the file and do the historian ingestion on the other side. Now, the second use case I just want to discuss here is the secure database replication. So here, two common databases you see in the OT side and the enterprise side. So one will be like your relational database. Another one is like a OT specific process databases like Aviva Pi kind of system. So a common deployment we have across the region is for the Pi deployments, where you have like two Pi system, which is running one on the OT side, one on the enterprise side. So the challenge here is always like, okay, if I have a historian sitting in the OT side, how do you safely give access to your business network, your low security side of your operation? So the traditional approach will be like you open up a port on the firewall. Now your firewall, it cannot be a high assurance box like a data diode. So you're running into vulnerabilities which can open up your OT operations to any attack happening on the enterprise side. So in this specific case, the use case will be something like, okay, I put a data diode here. Owl will provide you a pre-built connector for specific historian replication like an Aviva Pi, and you can replicate this historian to the business side. So the OT side users will use the Aviva Pi on the OT side, and a replica copy is created on the business side of the network. So this will be the one of the best solution in the case of where you want to give access to your business user to a historian solution. Another specific use case which comes in this scenario is like you have like a relational databases. So in that case, what happens is that we will be using a specialized connector which will replicate Microsoft database replication towards the business side, and you get a copy of the database on the destination side. Now, on the third use case, system monitoring. So this is a very common use case. We have deployments for all across the region, which is specifically to, let's say, I'll give an example, something like you have like a India solutions like IPS, IDS, you have certain assets which generate event logs like SNMP, traps, you have syslogs. So you will be running a network operations center or security operations center outside the OT environment. So how do you safely send this traffic towards your operations center? So the best solution what we use in this case is like, okay, you have like a diode placed there, and you will be using the UDP capability of a diode to transfer this event. So a better solution for that one is that we have a good integration with solutions like a Splunk, ArcSight, and SIM solution vendors in the market. So they deploy a heavy forwarder inside your OT environment where you can use this solution to do an aggregation of logs, and an indexer will be sitting on the business network. So you can technically transfer all these information on a safe way towards your network operation center, completely isolating your OT network from any threats from your business side of the operation. So these are the three common use cases. But again, this whole idea is that like Owl provides you the hardware, so you get the security, you have high performance, like you can go up to 100 Gbps now. So it covers most of the enterprise use cases on a high volume data transfer scale. You can have like different services built on top of it, because we are also working with other vendors to build solutions around it, where we have like tip platforms like cyber which is getting integrated through the diode. We are working on solutions for that one. So these are all proof of concepts and ideas which have been developed on the other side of it, where Owl is the transfer mechanism what these vendors will be using for safely providing a high assurance data transfer method. That's a key idea. And the key takeaway is that it's a high assurance device with higher bandwidth now, and it's just going to give you the same level of security which is expected from a air gap device. That's it. Thank you.
Thank you. John and Rohan has introduced to you so far the whole concept of data diodes, how it is a hardware-enforced one-way transfer mechanism. Rohan has now stepped you through some common use cases for the integration of OWL diodes into various OT to IT or two different security networks. I'd like to talk to you about the OWL products and how they accomplish what John and Rohan has described. So our latest, newest generation of the OWL technology is the protocol filtering data diodes. So as before, our solutions are a all-in-one solution that consists of the software license, the data diode module, and the various form factor of the host PC platform that will be the fit and function for your application. It supports multiple contiguous protocol and applications that support the various use cases that Ron mentioned. Some of them are, starting out with the basic UDP and TCP protocols, but file transfer, there's also the Pi database replication, SIM features like syslogs and SNMP messages, as well as NTP, and coming later this year, OPC UA, Modbus, MQTT, what have you. If you're familiar with OWL products, the OWL Talon protocol filtering diode support all those use cases and applications that you're familiar with. I think what's unique about the OWL data diode solutions are the extremely long mean time between failure numbers of our hardware solutions, as well as now we offer additional flexible pricing based upon your needs. So whereas before we had a type of a speed-based product offering. Now the basic minimum is a 1 gig throughput, starting with our Altalin 1 products. And as mentioned, we now extend that speed beyond to 10 gig, 50 gig, and even 100 gig offerings. So we offer the security of the hardware enforced one-way nature, multiple and continuous support of data flows, as well as a FPGA protocol filtering capability that I'll talk about in the next few slides. And also coming quite shortly in our August release will be high availability configurations of our diodes. Next slide. So here you see our first all-in-one solution. This is our 1U solution. It will install into any typical server rack solutions. It ships with a rail kit. So in addition to the mounting tabs, there's a rail kit option. It leverages partnerships with a handful of hardware vendors that we've partnered with. Logic is a US-based industrial PC manufacturer. They provide the appliance that is the host compute platform for our Altalin 1 card. That is the 1 gigabit per second supporting protocol filtering. It's a all-in-one diode module where it contains, in addition to the actual data diode module, a SOM with its own CPU that contains the source side instantiation of the Altalin 1 software. There is also a bidirectional configuration of this. So essentially, the bidirectional Altalin 1 consists of one data diode pointing out of the OT environment, as well as a second Altalin 1U unit pointing into the OT environment, both with its own data diode card and contains a additional layer of security to control that bidirectional solution. So it currently supports all those applications and protocol adapters, as well as a bidirectional configuration of this. Next slide. This is a new offering that we will be bringing out to the market next month. This is the same capable features as the Altalin 1U, now in a DIN rail form factor. Although it is shown in a kind of lying on its side with the heat sinks up top, it can mount vertically with the supply DIN rail clip. So it's just a different form factor to the 1U. It has all the same capabilities, the 1 gig Altalin 1 card, and supports all the Altalin 1 softwares and the protocol adapters. So you no longer have to choose one form factor for one price point. Both 1U option as well as the DIN rail options are available to you for roughly the same price. So it becomes just a matter of whether a 1U form factor, typically in a server room environment, or this DIN rail, which is really more intended for the factory or the operations floor alongside your other industrial equipment, and the same sort of functionality will be available to you. In the next slide, I will introduce to you our higher speeds. These are the same Altalin 1 software. However, it is a higher throughput torrent card pair that installs into the subsequent platforms that I'll describe. What is good and seamless for your operations is this torrent-based solutions still runs the same Altalin software solutions. So the look and feel, the configuration procedures, all of that will be consistent regardless of the hardware and the speed capabilities that you choose. So there'll be no new interfaces for your operations folks to have to relearn based upon the solutions. This Altalin Torrent 1U platform is the Supermicro Twin Server. So it's a dual node compute platform. So inside this one enterprise server, there's two CPU platforms with one torrent card installed on, let's say, the left side for discussion purposes. That would be the source side representing your OT network. The second torrent card, the receive card, will be installed on the right side on the second CPU representing your operations, or I should say your IT or lower class network. So you have a all-in-one solution that supports in one configuration speeds up to 10 gigabits per second. A second configuration is a 50 gig solution. And the initial use case that will be supported out the gate is high-speed file transfer. And we will continue to add additional Altalin software capabilities with subsequent releases where all the other protocols that we talked about, such as UDP, TCP, SNMP, and so forth, all of those capabilities will be supported in following torrent releases. Next slide. This is a 2U implementation of the torrent solution. These are now two Dell R6615 platforms, very, very powerful enterprise servers. So whereas in the Torrent 1U, the torrent card pair was installed in side-by-side compute platforms, these are separated out to two units because we're talking about extremely high throughput requirements here. And typically, I'll say that a typical operational environment doesn't need speeds up to this. The network itself has to be capable of supporting both feeding the send unit of this Torrent 2U solution, as well as then taking the data from the destination once the data transfer has happened across the data diode network, and taking the data, transferred data from the receive Dell R6615 units and sending it over to your final destination. So it's a very, very powerful and capable operations, and we're glad to be able to provide that range of solutions from 1 gig throughput hardware platforms all the way up to 100 gig throughput. So to summarize in the next slide. So here's a kind of a high-level comparison of our protocol filtering diodes with respect to some of our competitive solutions like firewalls and unidirectional, or more what we refer to as more simple diodes. I think the key point here is that this is hardware enforced security, so it's a immutable solution, right? Software, as capable as they are vulnerable to to zero-day exploits, or most often is the case where just misconfigurations or failure to patch to the latest CVE patches. The Talon PFDs have this hardware enforced nature. When you look at the total cost of ownership compared to some of these other solutions, it has a very low total cost of ownership, where the ongoing maintenance costs are much, much lower. The low latency that we talked about, and the fantastically long MTBF that's really intended for the operational implementations of this, and is a much easier solution to configure and put into operation. And that speed to put into operation, I think, is another really nice benefit of implementing a Talon diode. So thank you very much for this opportunity to introduce our products to you and to be able to explain some of these data diode approaches. Back to you.
Okay, wonderful. Thank you very much, gentlemen, for your presentation. Very, very thorough overview of I suppose, the challenges that practitioners and security leaders are facing in this space, but also a really good demo of the capabilities that you have there. I've got a few questions, and I can see a couple of questions that have come in through the question panel from the audience. A couple of them around the two-way communication piece. Would you be able to elaborate a little bit more about how that two-way communication works? Because I think there may be concerns from a couple of the audience members there about two-way communication potentially causing issues. So any sort of answer to that question from you gents on the call today?
Sure, I'd be glad to go into that. Yes, so it does seem counterintuitive that there's a two-way diode, because the whole concept of data diodes came into being because you wanted to enforce the data transfer out of your OT network without allowing a conduit in. So it is not a firewall where you have two ports opened up and one port controls data coming out and the other port controls data coming in. So a analogy that one of my colleagues uses quite often is a very good example of that. So as business people, we are traveling to the airport all the time. So if you think about the airport analogy, there is, when you first get to the airport, there is security measures in place. They check your passport, they check your identification, make sure you are who you are, and that you have a destination with an airplane ticket in mind. So you go through that security check, you travel to your destination, and on your return back to your home base, you don't go back through the same security checkpoint. There is a completely separate security check where they make sure that you exit the airport and you cannot go back into the airport. So two separate security mechanisms, right? They are not the same mechanisms, but nevertheless, you've made a round trip. So you could think of a bidirectional data diode in that sense. So we have two unique hardware units, right? One use solution that points out of the OT environment with a second hardware enforced data diode pointing back in. There's security measures to make sure that you are who you say you are, right? So credential checks, and therefore using two different security mechanisms and two separate one-way data flows, you can complete a round trip destination. So it's very different model than a firewall where it's the same hardware appliance, with the same login credentials and communication back and forth. So I also saw that someone had a question about whether the DIN rail form factor supported this. So for our initial implementation of the bidirectional talent, it currently is supported starting out of the gate, the 1U form factor. In a future release, we will also support a bidirectional use case on the DIN solution. It does, just like in the 1U, it will require a separate SKU. So the second SKU has a additional data NIC installed in there. So if you purchase a 1U unit, it's not like you could download a little bit of software and all of a sudden that turns into a bidirectional solution. You will have to make sure that you are purchasing the right configuration of that appliance if you intend to use it for bidirectional. So that's another layer of security, if you will, is you can't turn a one-way solution into a bidirectional solution just with a software hack, if you will.
Okay, fantastic. You alluded there actually, Phil, to the second question that I'd like to ask, and it was around the major differences, I suppose, between the solution that you have here and traditional firewalls for critical infrastructure security. So for any of the audience on the call today that might be thinking about transitioning to your approach rather than traditional firewalls, would you be able to summarize, the major differences that your solution and firewalls have and some of the benefits?
Sure. And John, Rohan, feel free to hop in. But I would say that the primary difference between a data diode and a firewall is software versus hardware. Not that the OWL data diode does not have software, but our primary defense, if you will, of that backwards channel into the OT environment is that our solutions have no physical mechanisms within the appliance itself that allows that communication back into the OT environment. So there is literally a air gap, if you will, on a microscopic level, but there is a physical air gap that enforces that one-way transfer out. And therefore, it's not vulnerable to misconfigurations or a delay in patching or that kind of unprotected channel back into the OT environment.
Okay. Thank you. And I can see a question from the audience, and it's around compliance mapping with IEC 62443. Now, we always get this question at the ISF around mappings between international standards and the IEC 62443 OT standards. Now, any answers for that particular question?
That one, I think it's a very good question. I don't know that we have a specific mapping document for 62443, but we really should. So if you think of obviously it's a similar concept to the Purdue model where, you're trying to move data in a specific way between lower sort of process and control zones at level 1 and 2 up to level 3 operations and out to level 4 on the business network. With 443, the concept is more about zones and conduits, if I recall correctly. And the diode can be used, and quite often, a lot of these use cases that Rohan showed earlier, we typically exist between a level 3 in the OT operation and level 4 on the IT side. Sometimes they'll refer to this as a level 3.5. So in terms of 443 concepts of zones, it's a way to move between those zones safely, depending on what security level within that standard you're trying to achieve. Another way to look at it is that rather than having those strict levels, 443 introduces this conduit idea. And so you can think of the data diode as a unidirectional conduit that allows you to move data with data integrity and confidentiality between the zones. And another thing to consider in general there is that you can use data diodes to safely move data outside of an operational network at any level. So we have many customers that are on the You could think of on the OEM side where they're monitoring an asset and performing a asset management or monitoring service for a customer, where the customer would prefer not to have that vendor connected directly to their OT network. So think of an electric drive in a refinery or a gas turbine in a power plant that the original vendor of that system wants to monitor. That might be sitting in level 2, let's say in a Purdue model or 62443. But rather than having to traverse the data all the way up the stack to the business network, you can safely take that data out at the lower level because there's no connection really to an outside network. So hopefully that's helpful, and thank you for that question.
Thank you, John. Thank you for your answer there. Now I can't see any more questions from the audience, so I would assume that nobody has any left. But yeah, look, I'd love to say and wrap this up by saying a big thank you to John, Rohan, Phil for your presentation today, and to the audience for staying around and contributing so much with your questions. Thank you for such an insightful session. For the audience, please do explore the websites at both our Cyber Defense and Oregon Systems. You can explore more by accessing the QR code on screen there. And of course, if you want to reach out to the panelists and presenters today, I'm sure we'll be able to provide the access there as well. But ultimately, thank you very much, Phil, John, Rohan, for your time today. I know it's very early in the US at the moment, so enjoy the rest of your day. And thank you very much to the audience. And we hope you enjoy the rest of your day as well. Thank you very much.